Today we're going to be talking about the triangle inequality theorem. And this is kind of a fun theorem, I think, for figuring out if three sides can make up a triangle. So our triangle inequality theorem. Two sides of a triangle must be larger than the third. That's all it means. So PQ plus QR has to be bigger than PR. Because if you think about it, if Q was in between P and R, PQ plus QR would equal PR, would equal our segment. But the second that Q is a little bit bigger, that we raise Q up, you're going to have a triangle, so PQ is going to be greater than QR. The same thing holds true with all the other sides. So QR plus PR is greater than, PQ. So the sum of any two sides of a triangle must be greater than the third side. Okay? All right. Let's get to some examples. Okay. So is it possible to have a triangle with the given sides? So take your two smaller sides and you're going to take 6 1/2 plus 6 1/2, and we're going to see, I don't know, is that greater than 14 1/2? Well, 6 1/2, 6 1/2, that's 13. 13 is not greater than 14 1/2, so no triangle. Take your two smaller sides. So my two smaller sides are 5.1 plus 6.8. Is that greater than 7.2? 11.9 is greater than 7.2. So yes, they can form a triangle. Okay. Find the possible measures of xy in triangle xyz. Okay, so I just want to show you guys x, y, z, not necessarily to scale. Okay, to do this, to get the possible values for xy, there's going to be a range. You take the other two sides and you add them together. So xz plus yz. And then you take the sides and you subtract them. Always do the largest minus the smallest. I'm just going to use yz minus xz. Okay, you never want a negative number here, but you're looking for a range. So you take the numbers and you subtract them. So 3 minus 2 is 1. That's the smallest xy can be. The largest it can be is if I were to add them. Okay, so again, you subtract. Subtract the two numbers to get your smaller number. Add the two numbers to get your larger number. Subtract the two numbers to get your smaller number. Add the two numbers to get your larger value. Okay, so those are fairly easy ones. Now this one, we don't know what the smallest and largest and all that stuff is. So we have to set up an inequality. Okay, take two sides. Is that greater than the third side? Is that greater than 3n minus 2? Solve for n. I am going to subtract the 2n over, add the 2 over. So n has to be less than 7. Let's see how our other inequalities play out. So I'm going to now take n plus 3. Add that to 3n minus 2. That has to be bigger than n plus 2. So I have 4n plus 1 has to be greater than n plus 2 for 3n greater than 1. N has to be greater than 1/3. And now lastly, we have n plus 2 plus 3n plus 3n minus 2 has to be greater than n plus 3. So 3, 4, n is greater than n plus 3. I subtract, I get 3n greater than 3, n is greater than 1. So now I need to figure out, I know definitely n has to be less than 7. So I know part of my answer is n is less than 7. But I need to decide between these two. So what I kind of want to show you is if this is 0, 1, 2, 3, 4, 5, 6, 7. This is a compound. We're going to come up with a compound inequality. An and inequality is the statement where all of the inequalities are true. So let me just show you. N is less than 7. Okay. Graphing that on my number line, n is less than 7. N is greater than 1/3. And n is greater than 1. So basically what I'm asking you here is what area have I shaded all 3 times? Where do when I'm graphing my inequality, where do all 3 inequality graphs intersect? What numbers do they intersect? They intersect from 1 to 7. So I know 1 is going to be my smallest possible number. Now, I kind of want to prove that to you guys. So let's test if n equaled 1/2. If n equaled 1/2, we'd have 2.5 for a side, we'd have 3.5 for a side, and we'd have negative 1/2 for a side, negative 0.5 for a side. I can't have negative 1/2 even for a side. If you think about it, what if I tried 2/3? Let's see what we get if we have that. So I would have 2 2/3 plus, I would have 2 2/3. I would have 3 2/3. And then I would have 2. Oh, minus 2. I would have 0 for a side. So notice how every time I'm plugging in a number here between 1/3 and 1, I'm not even getting a nice value for this third side. I'm going to try 0.9. So when I plug in 0.9, I get 2.9, 3.9, and let me use my calculator here. I get 0.7. Hey, that makes sense. Okay, could I have a triangle? I take the 2 smaller sides, 2.9 plus 0.7. Is that less than 3.9? No. Is that greater than, I should say greater than 3.9. That ended up being 3.6, greater than 3.9. Okay. So I tested a few numbers in between here and I came up with all possibilities not triangles. So you start with basically where your graph is, where all 3 of your graphs intersect. Where all 3 are being shaded. I'm always poor at trying to explain that. It makes sense in my head. I'm always poor at explaining that. I apologize. Okay, that was your video on the triangle inequality. I hope you enjoyed the video.